Okay, I'm going to try to re-update your questions to follow up on Atheist Blind Chick. First thing I just wanted to say is that you have your own accent, to question somebody else's accent I don't think is appropriate. I can understand both of you fine. So we'll move on to the questions. Question number one about the balance of life and single. You put in the update prey that grows too strong to take over the planet, but I would guess you would mean a predator. But either way, there actually is an animal that has taken over the planet due to evolution, and that's us. We're humans. We now control the entire planet. Any part we don't live or control, we could easily move there and take it over. I mean, we're this close to growing vegetables and fruits in the desert. We could, live anywhere on this planet, remove any life form from that planet that threatened us, and we could end all life on this planet if the case so comes. Unfortunately, we've come to that point, but we are the evolution that has formed the perfect predator. But in regards to balance of nature, it's not always a perfect balance. That's what extinction comes from. Obviously, humans have impacted a lot of animals in extinction, but animals with predator and prey relationships has resulted in extinction. The ones that don't necessarily result in extinction are based on just continued evolution. One animal gets a little faster, the prey gets away. The predator either gets a little faster to catch up or gets a little smarter to know where they live and hide and goes and finds them there. Then that prey learns either to find a new place to live or could become extinct, as many animals have already done. It is a continued evolution, and your question of why didn't one become too strong to take over the planet, we're it. Second, chromosomes. Chromosomal question. Why can there be a lucky lottery twice and a new species? That's not how it works. It's a slow evolution. We change over time, and I know what your question is that you're saying she didn't answer, and I would suggest searching Ken Miller on YouTube. Ken Miller has done genome sequencing, and his genome sequenced both the monkey all across from the human to try to figure these questions out. The question comes in with the monkey has 48 chromosomes and we have 46, resulting into one less pair. So where did that pair go? It's chromosome number 13 is missing, and where did it go? It turns out that exact genome sequence that is missing from the monkey is, for gorillas and chimpanzees or orangutans, the large apes, is actually in a different place. We actually have a fused chromosome, which means two chromosomes from the monkey connected together, and this can be seen in two ways. First, by just seeing the sequences and matching them next to each other. The second is for looking in what's called telomeres. Telomeres are at the end of chromosomes only. That is their primary function, to be the end of the chromosome and complete the chromosome. If you look at our second chromosome, there's actually a telomere section in the middle. That means that two chromosomes connected at the ends and fused and stayed that way. That is not lethal. It could be, but in this case it's not lethal on most cases. And all of the current sequencing, genes, the entire genome is actually still there. The animal doesn't necessarily change. There might be small changes, there might be medium changes, but it's not a new species. It's a small change, and then you evolve from there. So a in-between species between us and our ancestors would be this one animal that got that fusion, and that animal then would mate with another animal. It would pass on its chromosomes, and those chromosomes, if it passed on the right one that had fused, would continue on, which obviously it had. And over time there'd be more changes to the individual genes to create humans from that, but it would not necessarily be an instantaneous change like you're expecting. And your whole thing with trying to create this by radiation and genetic mutations and things like that, people didn't understand when they ran those unethical studies that that's not how the world operated on large wholesale changes. They're small usually very small mutations. Otherwise, they don't result in offspring that can be viable or livable, as proven by these radiation studies with offspring that had large mutations that were just unsurvivable. So that's not what we're expecting from natural selection. It's small, it's a few base pairs in a gene changing, and suddenly an animal, its wings grow an extra, a few centimeters, millimeters, but it helps it, fly a little bit further, fly a little bit faster. That's the idea. And there is no sudden chromosome disappearing. It's fused into another set. Plover birds. Her statement still stands that you attempted to just gloss over. It's never been seen before. That photo you showed, it's not a true photo, it's photoshopped. There's never been a photo taken of a plover bird in the mouth of a crocodile. There are many symbiotic relationships that are, odd, but there's no seen symbiotic relationship of a large animal or bird or whatever in the mouth of another animal. Fish do it, but they're usually much smaller fish that the other animals is not usually fully paying attention to, or the cleaner fish that clean off sharks or other larger fish don't usually enter in the mouth, although some of them swim right by and the larger fish will eat them. But the advancement or the benefit of going into that dangerous situation is large enough that the species developed it as a continued ability. So I think, if you're going to keep going back to the plover birds, it's never been seen before, so you can't use that as a continued argument. You want to try another one, go ahead and use your photos, but you can't use a photoshopped picture with something that's never been photographed or never been seen. So if these continue to not answer your questions, I don't know where else you can go with it, but I strongly recommend for the chromosomal question you check Ken Miller.